So now that you've gotten kind of the big picture view of completable futures, let's zoom in on the completion stage methods that handle or that are triggered when a single stage completes. And we'll see that there's roughly a third of the completion stage methods fall under that category. So let's take a look at probably the simplest of these. This is the then apply method, which is triggered by the completion of a single previous stage. Here's the signature of that method. You can see it's got then apply, returns a completable future, and it's passed a function. This function is the action that will be applied to the result when the previous stage completes. So whenever the previous stage, which is often something like, for example, the result of supply a sink. So you do supply a sink, you get some result when it's done being run in the background, and then we apply a function to the result. It returns a completable future that contains the results of whatever action, whatever function was applied. So let's take a quick look at an example. We've kind of looked at this before, but now we'll just zero in on the then apply portion. This is the example we looked at before where we've got ourselves a big unreduced fraction, and we have a lambda variable called reduce that's going to reduce that big unreduced fraction. We use supply a sink to do that reduction in the background. And when that reduction in the background completes, the then apply method is triggered. So the then apply method will then go ahead and convert the big fraction that is now reduced into a mixed string. This is that conversion is a very fast conversion, right? It takes a while to reduce a big fraction, which is why we ran it asynchronously with supply sync. But converting the big fraction into a mixed string is very quick. So you usually apply then apply, or the non-asynchronous version of then apply, is typically intended to be used with synchronous actions that return a value rather than returning a completable future. And you'll see why that is in a second. And you'll see why it is in a second when we take a look at the then compose method, because we're going to compare and contrast then compose with then apply. Then compose, at first glance, looks very similar to then apply. It takes a function, and that function is applied to the previous stage's result. So that's pretty much identical to what we had with then apply. And it returns a completable future. Well, gosh, that looks almost identical in terms of the signature to then apply. But there's a big difference, a very important difference. And the difference is that the completable future that's returned from then compose contains the results of the action directly rather than a nested completable future. Now, it might not be at all apparently obvious where you would end up with nested completable futures anyway, but we're going to take a look at an example to make this clear. The way to think about this, at least at a high level initially as we get into the details, is then compose is similar to flat map on a stream or on an optional. And basically the way it works is if you use flat map or if you use then compose and you compose together multiple completable futures, you will end up with a single completable future. Whereas if you were to use then apply, you'd end up with nested completable futures. So let's kind of take a look at this and it'll help become more clear. So first, let's take a look at how you might use this, and then we'll talk about why it's better than using then apply. So you typically use then compose when you have asynchronous actions that return completable futures, whereas you use then apply when you have synchronous actions that return values, not completable futures. So what the heck does that mean? So let's take a look from my EX8 folder. So what we're going to do here is we're going to define ourselves a local variable called reduce and multiply fractions. And reduce and multiply fractions, as you can see, is going to be a function, and it's going to take a big fraction. I give a shorthand BF because it was getting too big for the slide, but BF stands for big fraction. So we take a big fraction as a parameter, as the value to the apply method on the function, and we return a completable future to the big fraction. And here's what it's going to be implemented as. We say completable future supply a sink, and then we say reduce the unreduced big fraction. So this is going to run asynchronously, so it's going to return a completable future. Okay, so far so good. And the key thing to note here is that this computation returns a completable future, not a value. Just remember that. It's going to reduce the big fraction asynchronously and return a completable future, which, when the asynchronous computation is done, will be triggered. We're now going to use then compose. And notice what we're going to do here is we're going to say then compose, and we're going to take another call to completable future, supply async. And we're going to take the result that came back after we finished reducing this. So we get the reduced big fraction. And now we're going to take that reduced big fraction and we're going to multiply it. So we're going to multiply the big fraction, but we're going to do it inside supply async. So this itself will also return a completable future that will be completed or triggered when the multiplication finishes in the background thread. Well, notice that we're returning a completable future, and then compose also returns a completable future. But because of the semantics of then compose, it will return just a completable future with the final result, not a completable future to a completable future. And you might say, well, how on earth would you end up with a completable future to a completable future? If you had used then apply instead of then compose, because of the semantics of then apply, you would have ended up with a completable future to a completable future, which would have looked something like this, which, as you can imagine, gets to be rather convoluted very quickly because you have, completable futures to completable futures, and it just starts to get unwieldy. So the nice thing about then compose is you can use it to denest otherwise nested completable futures, whereas then apply would end up with nested completable futures. Now, it turns out that you can get around this whole nonsense of having to use then compose for this particular use case by using a variant of then apply. There's another variant of then apply called then apply async, which is a super cool variant which works like calling completable future supply async, but it doesn't nest the completable futures. So if you use then apply async, it'll run this computation, which is multiplying the reduced big fraction, in a different background thread, just like we would have gotten had we used supply async, as we show here, but you don't end up with nested completable futures. So just a little idiom to realize is that then apply async can often replace the use of then compose and supply async. And you'll get a chance to play around with this when you do programming assignment number 3, because you'll get a chance to use variants of then, you'll get a chance to use then apply async, you get a chance to use then compose async. There's a bunch of different cool things you get to do. You can also do some other tricks here. This is something that I don't necessarily recommend, but just be aware that it exists. You can also use a supply async with a long-running computation that returns a completable future, and then you can use then compose with function identity, and that will go ahead and basically do some additional denesting if you need that. Or, if you don't want to do this kind of nonsense, you can use then compose async, which is yet another way of being able to do things that return completable futures in a denested way. So you'll get a chance to play around with then compose async and then apply async in programming assignment number 3. So just be aware that there are these variants of these different methods. The next method we're going to talk about, the next completion stage method that is triggered by the completion of a single stage, is called then accept. And you can see it takes a consumer, which is the action to perform. Remember, a consumer is something that is going to take a value but not return a result, which it's the opposite of a supplier. A supplier doesn't take a parameter and returns a result. It's used typically as a source, and a consumer is typically used as a sink. It consumes something, and it'll apply this action to the results of the previous stage when it finishes running asynchronously. And this action behaves as a callback with a side effect. And it returns, using the word loosely, it returns a future to void. That just means it doesn't have a return. You can read more about Java's void type down here at the link at the bottom of the slide. We typically use then accept to the extent that we use it at the end of a chain of completion stages where we want a side effect to do something. So this particular example is just fleshing out what we showed before. We apply supply async to reduce the big fraction. We then call then apply to convert the big fraction to a mixed string. And then when that's done, we've got a string, or completable future is a string. When we're finished with that, we call then accept. and that turns around and has the side effect of printing that result to the standard output. So we're using the system.out::println method reference to print the mixed string when we're done. The one downside with using then except is if you're not careful, you can lead to something known as callback hell. This is a big problem in languages like JavaScript, which don't have as comprehensive a set of asynchronous operations as we see with CompletableFuture. CompletableFuture was thought through much more carefully than the JavaScript. I think they're called promises or futures or something in JavaScript. So you can end up with this really crazy, weird, unwieldy nesting known as callback hell. So if you want to amuse yourself, Google callback hell or just click on this link and you'll find out about callback hell. You do not want to be sent to callback hell. You want to do other things using then accept or then accept async or then compose async. You want to avoid that whenever possible.